everyone. My name is Chasen Hara, and I'm really excited to introduce you to a framework called Done.js, which has a focus on performance, usability, and maintainability. I'm going to go over what Done.js is, how single-page applications are built, both traditionally and with Done.js, and then we're going to go into an example of building a performant and usable chat app with Done.js. So first, let's talk about what Done.js is. So Done.js is an open source JavaScript framework. It's MIT licensed, so you can use it for whatever kind of project that you want to. It's backend services agnostic, which means that you can use Done.js with any sort of backend APIs that you want. You can be writing your backend code in Ruby or Java or PHP or what have you, and you can use all of the Done.js libraries in the front end. Now, it does have some server-side rendering packages and modules available so that if you want to do server-side rendering, you can run a Node.js backend. But it doesn't require all of your APIs to be written in JavaScript or what have you. And Done.js is built on top of a bunch of other open source libraries. So CanJS is an MVVM framework, kind of similar to Angular, Ember, etc. Steel.js is a module loader and bundler. You can kind of think of it as your Webpack or Browserify, what have you. Testy, FuncUnits, and these are all libraries that make testing a lot easier. And you can use it with QUnit, Mocha, Jasmine, etc. Document.js is a documentation generator, kind of built on adding JSDoc comments to your code and then being able to create documentation from your code. It's really cool. Unfortunately, we're not going to have time to get into it today. CanConnect and CanSet are related to the model layer and being able to connect to your APIs and do intelligent things based on them. We'll get into those a little bit more. And then Done.SSR and CanSimpleDOM are Node.js libraries for being able to server-side render your code so that the same code that you're writing to run on the front end can run on the back end with a DOM implementation for Node.js. We'll get into server-side rendering a lot today. Done.js supports Chrome, Edge, Firefox, the usual suspects, IE9 and later, and Safari, and we test for desktop and mobile, so your apps will work on iOS as well. The CLI, the Done.js CLI, can be used on Linux, macOS, and Windows. We support back to Node 4 and later. Today, our demos are going to be with Node 8 and NPM 5. And then the thing I want to really emphasize is that Done.js is not another new framework. So if you've been suffering from JavaScript fatigue, Done.js might be new to you, but it's not a new framework. To go back a little bit, all of these libraries that make Done.js, they all started back in 2007, beginning of 2008. We released JavaScript MVC, which contained all of these things. It was kind of a monolithic framework. And then over the years, in 2012 and later, we started breaking JavaScript MVC into its useful pieces. So CanJS just focused on being an MVVM framework. Steel.js just focused on module loading and bundling, etc. And then we rebranded all of these together, the culmination of all of these projects into Done.js at the end of 2015. So Done.js is a little bit new in name. It's been around for almost 2 years in name, but it has a history that's a lot longer than a lot of the current flavor of the month, flavor of the year frameworks, and has certainly outlived some frameworks too. It has performance features that make it as easy as possible for everyone to create world-class applications that do everything that's listed here on this slide. And to give a little bit of background, I'm part of the Done.js core team, and Done.js's main corporate sponsor is a company called Bitovi. We're a consulting company, and we've been making these tools for as long as the company has been around. And we've worked with a lot of large clients on some of the largest websites in the world. And what is in Done.js is all of the features, all of the things that make it possible for us to build these world-class applications. Everything that we've done for the quote-unquote big dogs. So as we'll see in this talk, things like server-side rendering, progressive loading, minimizing data requests and DOM updates, worker thread rendering, deploying to CDNs. We don't think that these things should take extra engineering effort to make happen. And they should work by default, and they should work seamlessly together. On the usability side, Done.js has a focus on making your app more usable by enabling real-time functionality, enabling two-way routing so that your URL is updated with application state changes, and then when that URL is loaded again, the user is put right back where they left off if they bookmarked it or sent a link to someone. As mentioned before, IE 9 Plus, and then all of the kind of latest browsers, both desktop and mobile. And then we support creating Android, iOS, Mac, and I think Electron and NWJS support Windows and Linux applications as well. So just about any native platform you can build an app for. And we make that really easy with Cordova on mobile, and then Electron and NWJS for desktop applications. And then Done.js also makes it easier for developers to get things done quickly because of our focus on maintainability, making sure that your application is maintainable over the long run. This includes comprehensive testing, tools for the entire testing lifecycle that make it easy to write, run, and maintain tests. Hot module swapping, so as you're making changes to your JavaScript and CSS or template files, those are all automatically reflected in your browser, and you don't have to refresh. This is amazing if you have not used hot module swapping or hot module reloading before. I don't like the word reloading because you're not like refreshing the page. Anyway, I really like that feature. I'll show it off later. Continuous integration and deployment. It's really important to be able to run your tests on every commit so you see problems earlier. And then automating deployment so you can release early and often. Using NPM packages is so useful for both being able to split up your HTML, split up your custom elements, and then share those, and then also to be able to consume others and consume those as NPM packages. Building your own custom elements, having an MVVM architecture for your front end, and then documentation is super important. I wish we were going to get into some of the documentation stuff that Done.js offers today. Unfortunately, we're not. But creating multi-versioned browsable documentation directly from your source code is really important. So that's part of our maintainability story. So with all of that in mind, I think it's worth talking about how single-page applications, or SPAs or SPAs, are built. We're going to compare how they've traditionally been built and then recent advancements over the years, and how Done.js improves the performance of single-page applications. So let's start off with a traditionally built SPA. How many people have built a site that looks like this, where it just renders an HTML skeleton, and then you've got one production CSS file, you've got a loading spinner while everything loads, and then you've got one JavaScript bundle that has your entire application? How many people have built something like this before? Yeah, basically everyone, right? It's super simple, but it's not performant. Let's get into that. So from start to finish, there's a lot of things that go into kind of a poor user experience. So to start off with, the user first navigates to the page, and then the HTML that we just talked about, that's going to be sent back to the user, right? And then they're going to see a loading spinner as the page's JavaScript loads. So loading, the CSS and JavaScript download. And the thing is that this usually takes longer because if you're just bundling all of your CSS and all of your JavaScript into one bundle, then it's a lot larger than it needs to be. So it finally downloads, and then your JavaScript kicks off and starts running. But the user is just going to see more loading spinners because it doesn't have the data that it needs to display to the user. So all in all, this results in multiple round-trip requests before the user can actually see the data that they care about and then interact with it. Let's compare that to Done.js. So with Done.js, we really strive to make a much better performance story out of the box where you don't really have to do anything to get a single page application to behave performantly. So when the user first navigates to the page, we're going to respond with a fully rendered HTML page with all of the data that the page needs. So the user can immediately start seeing what they actually care about. You can choose to have your CSS inlined, so the user is not seeing the unstyled content and then flashing to the styled content. They're actually seeing a usable application. This is before the rest of the JavaScript has loaded. And that's okay because even things like links that are in the page, those should just work. The user is able to see what's on the page and then start thinking about their next action while everything else is downloading in the background. And then we're going to load the minimal amount of JavaScript and any additional styles that are necessary for the page. Once the JavaScript is loaded, it's going to kick off and run normally. But it's going to make those data requests, and it's not going to actually need to make a network request because all of the data is already in the page that was returned from the server. So we trap those, and we don't have to make additional network requests for data that's already rendered on the page. So there's no additional round trips. It's just when the JavaScript loads, it'll kick off, and then the data will already be there, which is really, really cool. So the difference ends up being something like this. In the Done.js application, the user sees the fully rendered content a bit after the traditional spinner. We think this is okay because what they're getting is a fully rendered page that they can start scrolling through, start thinking about, and start considering. This has a huge impact on the perceived performance of the page. While the user is thinking about their data, JavaScript loads super fast behind it. And a lot of times, if the user is on a fast network, then it's gonna load very, very quickly, maybe even before they really start to try to interact with the page. And overall, we've seen this be a win in our client applications that are public-facing that need to render as quickly as possible. You can think of things like product pages and searches and shopping carts, what have you. We want to show the user their data as quickly as possible. We're working on some ways of making this even faster. So like right now with Done.js, if you're loading the entire HTML, the rendered page, the server has to do that, and then it has to wait until everything has been loaded before it can respond with the HTML page. We're working on something that allows you to do incremental rendering and start responding with the HTML as soon as any bit is ready. Even the API responses don't have to come back in their entirety before we can start spitting out parts of the page. So we're really excited about making this even faster. So now that we've talked about how single page applications work, I want to show you how easy it is to build a real-time chat application with arguably the most important subsets of Done.js's features, those around real-time and performance. So let's get started. We're going to build this chat application. It's really simple. This is from our quick start guide on Donejs.com. This chat application is super simple. It has a home page, which has a couple of tabs that you can switch through, and then the start chat button. And this links to this chat, sort of this messages page, where it just lists the messages, and then you can enter your name and your message, click send, and add a message. And this is all going to work in real time. So Done.js is focused on the front end. It does have the backend portions for server-side rendering, but we're not going to get into implementing a real-time chat server. We're just going to be focused on all of the front-end stuff today. So this chat app is going to have all of Done.js's awesome performance features that we just talked about. Server-side rendering will be progressively loaded. We'll have a fall-through local storage cache. It's going to be real-time. We're going to deploy to a CDN. We're going to use Firebase. Throughout our development, we're going to enjoy hot module swapping. We're going to use NPM packages for some of the functionality. We're going to build our own custom elements and use generators to be able to scaffold things a lot faster. These are the steps we're going to follow. First, we're going to set up a new Done.js project. We're going to add Bootstrap and check out hot module swapping so you don't have to hit refresh. We're going to add routing between two pages and use components for those. We're going to flesh out the messages page and connect it to our real-time service. We're going to finish the home page, and then we're going to build for production and deploy to Firebase, our CDN. So these are 7 steps, and then if we have time, we're going to have an 8th step that I think is pretty cool. So let's get into it. So let's go to our terminal. And we're going to install the Done.js CLI. So we're going to run npm install -g Done.js. And that's going to install a CLI that is available to us wherever, which is useful because the next thing we're going to do is create a new project. For that, we're going to run Done.js add app. Let's go ahead and do that. So Done.js add app. We're going to call it Done.js chat. What this is going to do is it's going to create a new project folder for us called Done.js chat and install some npm packages. And then the CLI is going to prompt us with a couple of questions to fill out our package.json. So the project's name, description, npm version, the license. After we fill that out, it's going to create all of these files for us, and we're going to talk about those in a little bit more detail later. And it's going to install all of the node modules that we need for our project. Let's go ahead and clear this, and then we're going to we're going to switch into the project directory, and then we're going to run Done.js develop, which is going to start a local development server. With that started, we can switch over to our browser and load localhost 8080, and you can see that it loaded a page. It loaded a hello world page. Now let's go ahead and open our project that we just created, and Adam is going to be our editor. We can check out these files that it created. Most of our work is going to be in the source directory, where it created a models folder and a fixtures folder inside of that. If you haven't used fixtures before, I wish we could have a whole talk on that. We won't get into. There's a test file for our models, and then there's a main app.js file for our kind of the roots of our application. Index.md for documentation, index.stash. We're going to be using a handlebars or mustache-like syntax called stash. And then we've got some styles in less and a test file. So those are all of the files that the Done.js CLI created for us. So next I want to show off live reload. So let's open that index.stash, and we're going to add a paragraph, but you'll notice I'm not going to hit save yet, right? You can see the little blue indicator up there that says I haven't saved yet. So I'm going to save, and when I do, you're going to see the browser on the right-hand side is going to immediately update with the paragraph that we just added. So let's go ahead and save. Boom. There you go. So as soon as we saved, we didn't have to refresh the page. The development server that we have running in the terminal sees the change and then tells the browser, hey, there's this particular part of the application has changed, and then replays that change in the browser. And we've got hot module swapping. Okay, cool. So now with our application all set up, let's go ahead and add Bootstrap. So we're going to go back to our terminal where we have the development server running. We're going to go ahead and create a new tab in our terminal, and we're going to run npm install bootstrap. Again, because we're using npm5, so we don't have to write -- save to have it update our package.json. Let's go ahead and switch to our editor, and I'm going to go ahead and copy this statement, this import statement, which allows us to bring in other modules. So we're going to can import from bootstrap less, and then the main bootstrap.less file. And then we're going to replace what we have there and go ahead and watching someone type bootstrap styling is super boring, and that's all this is a couple of divs, an h1 with an image. We're going to have the Done.js logo and then chat as part of our h1. And then again, I love live reloading so much. So I have to do the dramatic pause. We haven't saved yet. And then I'm going to go ahead and save. And when I do, then we're going to see the browser automatically update. So let's go ahead and hit save. And boom. We've imported Bootstrap. Those styles are being applied to the page, and we have the divs and h1s that we just added. So I think that's pretty cool that while the live reload server is running, we can run npm install and start using new modules, and we don't have to restart our development server. Cool. So now let's talk about routing and components. So in this step, we're going to add routing between two different pages. We're going to have a home page, which is going to be represented by the chat home components or chat home custom elements. And we're going to have a chat messages page with all of the messages. So let's go ahead and go back to our terminal. Done.js has generators that make it really easy to define custom elements or components. There's kind of two ways you can define components. The first is within a single .component file. Let's go ahead and start off with that. So I'm going to run Done.js add components. We're going to call it home.component, and we're going to give the custom element or the component name chat home. So it created that home.component file for us. Now we can go ahead and switch to our editor and open that home.component file. Actually, first, let's take the h1 that we had, and then we'll add that to the home.component. So you can see it's broken up into a few different elements. There's a style element, there's a view element, and then there's a script element. For our case, our home component is really just going to be the view and the styles. So the view is going to be that h1 that we had before, and it's also going to have a link back to, or it's going to have a link to the messages page. So we imported can/slash helpers route, which gave us that route URL helper that we're using in the href in this button. So we're going to have the start chat button that is going to link to the chat page. We don't need a script. We don't need any special JavaScript for this component. It's super simple. But we do want to customize the styles a little bit. So we're going to add some CSS up there. Cool. Okay, so now with our home component, we can go ahead and make the messages component. So let's go ahead and switch back to our terminal. And then we're going to run Done.js add components, same as before. This time we're just going to say messages. So it creates a messages folder with all of the files. And then we're going to call the custom element chat messages. You can see all of the files that it created: an HTML file for demo, JavaScript file for any interactive bits, MD, the markdown file, less for styles, stash for our template, and then a test JavaScript file for writing our tests, and then a test HTML file for being able to see our tests in the browser and run them individually. We call these modlets. I think this is a super useful pattern for having all of the things that are necessary for a component in one folder, and then specifically having separate files for tests and for being able to see a demo of that component, etc. Okay, so we have our messages component. Let's go ahead and switch back to our editor, and let's open that messages folder. And let's make this a little bit wider. And now we can modify the template. So let's replace the paragraph that's here. And we're going to do a similar thing that we did in the homepage. We're going to import the can/slash helpers route module that'll give us the route URL helper. And then we'll create a link that is back to the homepage. So we'll say route URL. We want the URL for the homepage, and close that out. Cool. Now we can add the routes that we've been using. So we'll open the app.js as kind of our root JavaScript file. This app view model is kind of the root view model for our entire application. So we're saying that there's going to be a page property that is a string, and then we're going to use the can route module that we import on line 2. And we're going to say whenever the URL looks like /something, that something is going to be the page property in our view model. And by default, we're going to say it's home. So if we're at just /, then the page is going to be home. Otherwise, if it's / something like /chat, then the page property is going to be set to chat. All right, the last thing that we need to do is to actually use these components. So let's go back to our index.stash, and here where we had the h1 before, we're gonna put in a couple of cases. So this EQ helper is for saying, hey, if the page property in the view model is equal to chat, then we want to use can import to import the messages model. And inside of that, we're given a promise. So we can say if the promise is pending, if it's still fetching the JavaScript for that component, then show loading. Otherwise, we're going to use the chat messages custom element. And then our app is super simple. There's just a chat page and a home page. So we're going to cheat a little bit and just say else. Say if we're not on the chat page, then we're on the home page. So we're going to import home.component. If it's pending, show loading. Otherwise, use the custom element. And this is how we do progressive loading, right? It's only going to load the code that's necessary for any given page. So when the user just hits the home page, then the home component is going to be server-side rendered, but none of the messages code is going to be loaded. And then when they click on the start chat link to go to the messages page, then we can progressively load the rest of the JavaScript and other assets that are required for the messages page. You'll notice I haven't saved. Dramatic pause before I save, because we're going to see the live reloading in action, or the hot module swapping in action. So let's go ahead and save, and save. And then we see our start chat button. And then when the user clicks on that, they'll be able to go to the messages page, and then they'll be able to go back to the home page. Before we move on from this, I want to show what the server-side rendered source looks like. So let's go ahead and we will open DevTools. We'll view page source. You'll see all of the CSS is inlined for development, but when we go to the bottom of the page, you can see the same structure that is in our template. So we're viewing source, we're viewing what is rendered from the server. We can see all of the divs from the template. We can see it just imported the home component, and then it rendered that chat home custom element with its contents. All right, now let's make the messages page. It's going to have a list of messages that come from the server. We're going to be able to put in a name message to add our message to the list, and it's going to be real time. So when we create messages, that'll be sent to the server, and then when other users create messages, then that'll show up in our list. To start, we'll start in the terminal. And I'm going to generate something that's called a supermodel, which is kind of a silly name. Done.js adds supermodel, and we're going to call it message. We're going to put in the URL to the server that has all of the messages. So that's the chat.donejs.com/API/messages. And then chat.donejs.com is kind of our service URL. It's the base for all of our API requests. And then we're going to say every message is going to have an ID property. And that's how we're going to uniquely identify messages from the service. That creates a few files. It creates a fixtures file, which unfortunately we don't have time to get into. And then it creates the main JavaScript file for the model, and then a test file for it. So let's switch over and take a look at the files that the CLI just generated for us. And here's the main message JavaScript file that created. Has a bunch of import statements, and then it's defining a couple of variables and then using them. So I want to go into those right now. Let's start off with how CanJS splits the definition of a model. So first, there's the type definition. So I'm highlighting the message variable because here we're defining that a message type, which says, you can see the second object that's passed in, that every message is going to have an ID property. And we're not making any assumptions about your model. Your ID property could be a UUID, so it could be a string. It could be an integer. We're not making any assumptions straight off the bat. And that is where we can add properties that every message has. And then the second part of a model definition is the connection, which is where we connect the data type to a URL. So when it asked us earlier if chat.donejs.com was our service-based URL, this is what it was filling out. It added that to our package.json, and then it makes it available to us in this loader module. So we can say our connection for messages should be at this kind of root URL, and we're making assumptions about it. We're assuming that we can post to this URL to create new messages, that we can get this URL to get a list of them. If we wanted to get the details for a specific message, we could use this URL / that ID, etc. If we wanted to update, we could do a put to a specific message resource, etc. These are all assumptions that CanJS makes, but these are completely customizable. You can change all of CanJS's behavior with how it connects to your API and how it makes and receives API calls as well. But these are useful defaults for any RESTful service. And if you're using a backend API that's made from something like Feathers, then it kind of follows those same conventions. All right, so now that we've pointed out some of the things in this model file, let's add some properties to our message type. So we're going to add a name property, which is a string, and a body, which is a string. So that body is going to be the body of the message. Now let's go ahead and switch back to the JavaScript for our message component. We're going to import that model that we just created. So import the message type from models / message. And then we're going to replace that kind of default property that we had before. And we're going to define a new property called messages promise, just using the ES5 getter syntax. We're going to say the messages promise is going to be the result of calling get list on our message model. And we're passing it an empty object because we want all of the messages, right? We're not filtering or sorting or doing anything with the list. We just want to get a list of all of the messages. And we want that as our messages promise property in our view model. Now let's go ahead and use that in our template file. So we'll switch to the stash file. We'll get rid of this paragraph that was showing a message before. Then we're going to say if the messages promise is resolved, then we want to iterate through all of the messages that were returned by the server. So we're going to say messages promise.value. That gives us the list of messages. We're going to have some standard Bootstrap styling. The big important parts here are in the H4, we have the double curlies and then name. So we want to show the name of the message or the name of the person who sent it, the message body. And we're going to do that for each message. Else, this kind of cool thing in Stash, we can say else. We're going to say no messages. Then when we click on the Start Chat button, the UI, we can go ahead and see that there's already a message. It's Adele saying hello. So this has been pretty straightforward in just getting a list of messages from the server and then iterating through them to show them. Let's actually work on being able to create new messages. Let's go back to our JavaScript file. What we're going to do is we're going to add a couple of things to our view model. We're going to add a name property and a body property, which are going to store the name and message of a message that we're creating. Then we're going to create a send method. It'll take in the DOM event, the submit event when the user fills out the form and hits submit. We're going to call it the prevent default. And then we're going to create a new instance of the message model. We're going to take this .name and this .body, which are from the components view model. We're going to create a new message out of those. And then we're going to call .save, which is going to make the post request to our API to actually create the message. And then when it's saved, we're going to reset the body to an empty string so that the user can fill out a different message body. But we're going to keep the name, so the same user doesn't have to fill out their name over and over. Next, let's actually use this in our template file. So at the bottom of this, we're going to create a new form. We're going to add a form for creating new messages with a name and body. We're going to listen for the submit event, and when submit is called, we're going to call our send method with the DOM event. Then we're going to have an input for putting in the person's name. We're going to copy this to kind of use as a template for our other inputs. Second thing we're going to have is the input for the message body, and then we're going to have a submit button for the user to be able to send their message. We can get rid of that. Cool. We've got our send. When we click save, or when we hit Control S, then we can see the inputs and the send button in our UI. Woohoo! Hot module swapping. Now let's go ahead and send a message. So we're going to keep with the Adele theme. Type in Adele as our name. Type in it's me. We'll click send. And our message is sent. And something absolutely bananas just happened right now. Can anyone spot the like crazy pants thing that just happened? Okay, how did that message appear in the list of messages? Right? If you've written any client code before, you know that you usually have to listen to like something being created from the server and then to update our list. We didn't do any of that, right? We just had our send method that created a new message and then called save and then reset the message body property so that it would be emptied out for the next message. But we didn't have to write any custom code for adding that message to the list, right? So how in the world did that magical thing happen? That was brought to us by set logic. We're going to talk about that in a little bit more detail in just a moment. But just remember, set logic. It's crazy. All right, let's go back to our code. At this point, I just want to point out the kind of local storage and fall through caching. So let's go ahead and open the developer tools. And we've got our local storage, and you can kind of see how CanJS stores these things. So it's got that set. That first row is for saying the set is all of the objects. We've got our instances, so we've got our first message and our second message, and then we've got our other, we've got our set with all of these, or with both of these items in it. And this is how we can do fall through local storage caching, where if the user, let's say the user goes to the homepage, right? They've used your chat application before, and they go to the homepage, and then they click on Start Chat. They're going to be taken to the chat page, and we can immediately render all of the messages that we have in local storage before making the API request to get to get all of the messages. Then, as that's happening, that when that API request comes back through the magic of observables, the UI will automatically be updated with any messages that were retrieved from the server. You don't have to write any code for any of that. It just works. It's kind of one of my favorite features of our library called CanConnect, which is responsible for all of the API connection stuff. So speaking of connection stuff, let's connect to a real-time service. Let's switch back to our terminal. And what we're going to do is we're going to install a package called Steal Socket.io. This is the same as the Socket.io you know and love. We have our own version of the package for server-side rendering because when the package is used on the backend, when it's server-side rendered, we don't want our socket connections to be left open. So that's why we're using the Steal Socket.io package. So now that we've installed it, let's go ahead and switch to our editor. And we're in our message model file. We're going to import the package that we just installed. Let's go to the bottom of the code, and we're going to create a new socket connection. So we're going to use that service-based URL property on loader again, which is chat.donejs.com. And then we're going to listen for a few socket messages. So the first is when a message is created. We're going to get that message, and then we're going to tell our message connection that a new instance was created. That's what that create instance is called. So we receive an event from our socket server that says a new message was created or updated or removed. So we need to be able to tell our model layer, okay, we need to create an instance, we need to update an instance with new data, or we need to destroy this instance. Now let's go ahead and switch to our space where we have Chrome and Safari open side by side. So in Chrome, we're going to fill out Hadel and a new message. And when I click on send, boom, it is on the Safari page as well. So how did all of this work? Well, all we did was tell the model when a new message was created. We handled that socket.io event, messages created, and we told our connection, hey, a new instance has been created. So kind of the magical part is, how did it know to add it to the list that was rendered? This is going back to the set logic that we talked about a little bit earlier. I'm going to diagram this, not using messages, but going for kind of the traditional analogy of to-dos, because I think it's useful for this scenario. So let's say I have a page where I want to show a list of new to-dos and assigned to-dos. So how would I write this app? Well, I would ask the connection for a list of new to-dos, and then somewhere else I might ask for a list of all of the assigned to-dos. Then the connection would go to the server and get some data back for each of these. And then those would be rendered to the page. Get the assigned ones, we get our ID 3, ID 4, we render them to the page. Now, behind the scenes, what CanJS does is it keeps something that we call a list store. So it sees the requests that were made, right? All of the objects of type new, and then it sees the data that was returned. All of the objects that are of type assigned, and what was returned. And this is what we call the list store, where we keep associations of requests were made and then the data that was returned. Now later, the server over the socket.io connection, it sends us an event, and then we call update instance. So in this case, the server, something else updated the object with ID 2, and it's no longer a new to-do, it's an assigned to-do. So the server told us this, and we call update instance. And then the list store can be updated and say, okay, I know ID 2 is no longer new, it's part of the assigned set. And then through the magic of observables and live binding, our UI automatically updates, moving the ID 2 to-do to the assigned section. So CanJS makes assumptions about your data. And if those assumptions are invalid, then you can kind of build your own set algebras to be able to configure things correctly and pass that to the connection so everything is set up correctly. But we use these throughout. We use the set algebra throughout CanJS to make some crazy performance enhancements. So another example is if part of the page is requesting all of the to-dos that are complete, and then another section is just requesting the incomplete to-dos, then CanJS can know that these are complementary sets, and that if I request all of the to-dos, then I don't also have to request all of the incomplete ones, because the incomplete ones are a subset of all of the to-dos. And CanJS and CanConnect is the package that is responsible for all of this crazy cool behavior. It does all of this logic for you. You might have to give it some configuration of what your data looks like, but otherwise it can figure these things out on its own, which I think is really, really cool. So that's how the set logic and real-time behavior works. Let's go ahead and finish the homepage. So we're going to add a tabs widget to the homepage. And kind of the point of this is just to show how easy it is to use NPM to install modules and then use them in your application. So we're going to install a module called bittabs, which, as you might guess, is a library for being able to show some like UI tabs. So we ran npm install bittabs. And now let's go ahead and switch to our editor. We're going to open the home.component file that we had earlier. We're going to import the bittabs module. We're saying we want to import the kind of unstyled version of this component. And then we're going to use it. So we're going to use the bittabs custom element. We're going to create 2 bit panels, one which says can.js and has some content, the other which says steel.js and has some different content. And let's close this out. And we can click on save. And we immediately see in our browser on the right-hand side the can.js and steel.js tabs. Let's go ahead and customize the styles a little bit. So we're going to say but panel paragraph element, add some padding. Boom, we saved. We can switch between these tabs, and we're good to go. Again, one of the things that I love about live reloading with Done.js is that you can run npm install this entire time, like literally this entire time we've had the development server running, and we've not had to restart it once for any of the npm installs or file changes that we've made. And in my experience, it's been fairly resilient. So if you make mistakes, which of course no one ever makes mistakes, but let's say you do, hypothetically, or one of your coworkers does. As you're developing, if you make mistakes, it's pretty resilient in being able to recover from that and not just hose your page so that you have to restart your development server. So I really like it. Okay, cool. So we basically finished our app. We've finished all of the important pieces of our application. So next we're going to build this for production and deploy it to a CDN. So first I want to show, we've been running in development mode, but I want to show why we even have to create a production build. So let's go ahead and open up the developer tools. We're going to open up the network tab. And when we hit reload, you're going to see hundreds, 292 to be exact. 292 requests being made just to load the home page, which is perfectly fine in development, right? You're just loading these files locally. It's fine to load every file individually. But this is crazy banana pants. If you want to put this in production, it's going to be terrible for your users. So this is the reason why we want to lower these numbers. We want to make as few requests as possible, and we want to minimize the data that the user has to load. So let's go ahead and switch to our terminal. This entire time we've had this development server running. Let's kill it and clear it. We're going to run Done.js build. What this is going to do is it's going to analyze all of our packages and transpile them and create all of the files that we would want to load in production. And now, instead of a development server, we're going to start a production server. So we're going to set our node environment to production and run Done.js start. So this is going to start our server in production. And that means it'll serve all of the files that we just built, all of the production ready files that we just built with Done.js build. Those are ready to be served. Let's switch back to our browser. We'll hit reload on the page. A, it loaded super fast, but B, you can see it's only 9 requests, right? Only 9 requests to load the homepage. If we look at all of those, localhost, right? We got to get the HTML, the server-side rendered HTML back from the server. We've got that SVG logo image, and then it's and it being Steel or Steel Tools. It's what's responsible for analyzing all of your code and figuring out the progressively loaded bundles. So what it does, or what it did, is that it figured out, okay, I'm going to have some CSS for just the homepage. This index.css is for all of the CSS that's common across the entire application. So this is something like Bootstrap, right? Steel.production is Steel being able to load things in the browser. So as you're switching between pages, it'll be able to progressively load the other pages. Index.js is the common JavaScript for everything. You can see that one's a little bit larger because it has all of our dependencies, right? It has all of the CanJS dependencies that we import. It has bit tabs. It has Steel Socket.io. Or actually, sorry, that's a mistake. It does not have Steel Socket.io. That's a really important thing because we're just loading the homepage here, right? So in our case, the Steel Socket.io was only used on the messages page to load the messages. So similar to how we have like a home.js page here, we would have a messages.js script if we went to the messages page, and that would have Steel Socket.io because that's just required for that page. And then it's looking for the favicon, and then it's loading what's another progressively bundled asset for the homepage. You can configure how Steel.js works. So let's say like we want, in our case, this home.css that's only 372 bytes. Right? We would want to have that rolled into maybe our index.css file or something, so we're not making another request for something that's so small. So Steel Tools is pretty configurable, and this is just kind of how it works out of the box, which is, pretty good to have everything progressively bundled and loaded so quickly. All right, now we're going to deploy this to Firebase's CDN. So you don't have to use Firebase, but it's the only CDN that we know of that lets you easily push from nodes. So we're going to sign in to Firebase, and we're going to create a new project. Let's go ahead and call this Done.js chat app. And going to click on create project, let Firebase do its thing. And then we're gonna need to get some details about the project that we just created. So there's a project ID that Firebase generates to uniquely identify our project, and that's what we're gonna need in just a little bit to be able to deploy to this app. So once we have that project ID copied, let's go ahead and switch to the terminal. We're going to run Done.js add Firebase. We're going to put in that project ID that we just copied, and the CLI is going to modify our package.json with the configuration that's required for deploying to Firebase. And it also creates that firebase.json and the Firebase configuration file. And it also installed the Firebase tools npm package, which we're going to use right now. Let's go ahead and clear this. And then we're going to go into our node modules and use the Firebase CLI to log in. that's going to open up our browser. We're going to log in again and authorize the CLI to, do what we want. Let's close that and go back to our terminal. Cool, success. We're logged in. That worked correctly. Okay, let's clear this, and then we're gonna run Done.js build again. So this is gonna go through the same transpile and minifying process that we went through earlier. So we have all of our progressively loaded assets. Let's go ahead and clear this. And then we're going to run Done.js deploy, which is going to run Firebase deploy, which is going to deploy to our project. So it uploaded all of the static files. So that's probably worth repeating, right? In this case, we're using Firebase as just a CDN. So it's going to upload all of the JavaScript and CSS and images, what have you, that are in our project, so they can be progressively loaded or loaded by our application. We are not going to show deploying this application to a service like Heroku, which would run your server and what have you. This is just for hosting the static files so that they're on a content delivery network. And then let's actually see these files being used. So we're going to start our server in production mode again. Run Done.js start in production. And then when we switch back to our application and reload, we can check out the sources tab, and we can see we're getting the server-side rendered file from localhost, but then all of the other assets that are for our application are being loaded on firebaseapp.com. So those are the ones that we deployed to a CDN. And now our app is able to load even faster around the world. All right, so I said that there would be an 8th special step if we had time, and we do have time. So we're going to use Cordova to build an iOS app version, and we're going to use Electron to build a desktop app. So if you're not familiar with Cordova, it's a tool for being able to it's a tool for being able to build native applications as a shell around your web applications, and it gives you integration into the native APIs as well. In our case, we just want to be able to have our chat web application rendered in a native shell, which we would be able to distribute to the App Store if we so chose. So let's go back to the terminal. And first thing, if you're on a Mac, is to install the iOS sim package, which allows us to actually use the iOS simulator. And then we're going to run Done.js add Cordova. And similar to when we ran Done.js add Firebase, this is going to prompt us for some details about our application. We're just going to accept the defaults, say our project name and the bundle ID. And then it's going to install all of the modules that are required for Cordova, for our application, and do all of the configuration based on our answers to the CLI. Next, let's go ahead and run Done.js build Cordova. And this is going to go through the same build process that we had before for progressively loading our application, and then create a binary, an iOS binary via Cordova. So that worked successfully. Woohoo! And next, let's go ahead and see our iOS application. So we're gonna switch to our desktop, and boom, we have it launched. And we can click the start button or the chat button. We can fill in a message, and on the right we have Safari with our app. And when we click on send, boom, the Safari application also updates. And we can see that everything is working from within our iOS Cordova build. And literally, it was that easy to get a build of our application with the iOS native shell. Next, let's do the same thing for Electron. Now, Done.js actually supports Electron and NWJS, so you can take your pick. Electron seems to be the favored child right now that a lot of projects are using. So we've added support for Electron. And we can basically do the exact same thing that we did for Cordova. That starts off with running Done.js add Electron, which will install that package, the Done.js Electron package. It will ask us some questions about our app. So we're going to say we want for Mac OS, and we're just going to make a 64-bit build for the Mac that we're running on. And it's going to install all of the node modules that are required for Electron as well. And then our next step is to run Done.js build Electron, right? Same thing as Done.js build Cordova. It's going to build our entire application and then package it use Electron to package it for a Mac. So we can see that last line that it built for x64. And now we can open the built Mac application. So let's go ahead and run open, just a command for opening binaries. So in our projects, there's a build and then the binary. This opens our Electron app. We can click on Start Chat. We can fill in a name. We're going to keep with the theme. Put in a message. And when we click send, boom, both on iPhone and in Safari, we can see they're all a happy family with all of the messages and all of the real-time. Everything just kind of works out of the box. Again, it was for Electron, it was as easy as Done.js add Electron, Done.js build Electron to create the binary. And that is it for our chat application today. So this was the quick start guide on donejs.com. We also have a even more comprehensive guide that builds an application called Place My Order, which goes into build kind of everything that's necessary for building a full-featured application. Developing it, testing it, setting up continuous integration, even setting up a continuous deploy. So you can check that out too. You can find us on the web. Donejs.com is our homepage for the project. You can also find us on GitHub. Again, Done.js and all of the libraries that are a part of it, CanJS, SteelJS, etc. They're all MIT licensed and all open source. Find us on Twitter @Donejs. And then definitely look up any other meetups. Thank you so much to JavaScriptLA for having me today, and Hack Reactor for hosting us. If there's any questions, I will take them afterwards. So thank you very much. Thanks for your time.